So good news, the next section, 1.5 is on Pythagorean Theorem. And you might say, we already did Pythagorean Theorem. We did, several times. And we just have to remember it for section 10.2. So what we did is we created this little half section in between to remind ourselves that Pythagorean Theorem is used for right triangles, right? Pythagorean Theorem is used for right triangles. Who remembers what the Pythagorean Theorem is? You are right. Pythagorean Theorem is a squared plus b squared equals c squared. Or sometimes we say leg squared plus leg squared equals hypotenuse squared. I'm just going to abbreviate that. So you'll remember that the legs are always next to the right angle. The legs are always next to the right angle. So like here, these are the two legs, right? And it doesn't matter really which one we call A and which one we call B. And then the hypotenuse is always across from the right angle. Or it's always the longest side, right angle, and the longest side. But we knew that already, right? So sometimes I like to go through and highlight the A's, the B's, the C's, especially the C. And then when we write our equation, a squared plus b squared equals c squared. And some of these will be what we call Pythagorean triples that we've done so many times that you might even remember by heart that it's x equals 6, or that 6, 8, 10 always works in a right triangle. But the reason we're going to be revisiting this now is now we're doing some harder ones, like here with root 4 and x and root 5. And again, it doesn't matter which one you call A and which one you call B, but the C has to be root 5. And so now you got to think about it. Well, what is the square root of 4 squared? Well, square root of 4 squared is square root of 4 times square root of 4, which is square root of 16, which is 4. And the square root of 5 squared is the square root of 5 times the square root of 5, which is the square root of 25, which is 5. So we had to do a little of that work first, and then we do, of course, that final square root, so x is 1. So a harder version of Pythagorean Theorem. This one doesn't look like it's harder, and by the way, you can assume that that's the right angle, so this is the hypotenuse. Of course, it doesn't matter which one you call a squared, which one you call b squared, because either way, they're going to add up here to 45. 45 equals c squared. C is square root of 45. So now we're going to see this exact versus approximate. We had that earlier, remember, where exact was pi and then approximate 3.14. It's similar where exact is always going to have a symbol. Approximate is always going to be a decimal. The exact answer, what we mean by that is the simplified answer. So the square root of 45 can be written as the square root of 9 times the square root of 5, and the square root of 9 is 3. The exact answer is 3 root 5. The approximate answer, I can just go to my calculator and type in square root of 45, and I'm rounding it to the nearest hundredth, 6.71. So exact is 3 root 5, approximate 6.71, and we're going to want both. Let's try this one. A squared plus b squared equals c squared. The a squared and the b squared are both 5. When I square 5 squared, I get 25 each time, which adds up to 50. So my square root of 50 is really my answer. But to get the exact answer, I have to simplify that. Square root of 25 times the square root of 2. And then the square root of 25, of course, is 5. To find the approximate answer, I'm going to type on my calculator square root of 50, 7.07, rounded to the nearest hundredth. Exact approximate. And that was a real intentional question. You're going to see in the coming sections why we chose those numbers. Same thing for number 5. We're not just choosing these numbers randomly. These numbers are going to fit a pattern that we will learn later. But for now, we're just doing the Pythagorean theorem. This is going to be square root of 48 which we've done. We know is square root of 16, square root of 3, or my exact answer is 4 root 3. And if I go to my calculator, I'm typing in square root of 48, 6.93. 6.93. And again, intentional question. The last intentional question has a 1 and a 1. So this one's going to be kind of nice because I don't think it's going to really simplify, is it? 1 plus 1 is 2. Square root of 2, well, that's just the square root of 2. And if I type it on my calculator, 1.41. Perfect. We've done these questions before. Do these sides make a right triangle? It's basically testing if the Pythagorean theorem works. But you have to make sure that you choose C for your biggest number, right? Because that's always the longest side across from the right angle. And does that work? Those add up. Yes, you're good. Here, the C would be the 8. Does 5 squared plus 6 squared equal 8 squared? Doesn't seem like it's going to, does it? 25 and 36, definitely not equal to 64, so that's a no. And then here you'll see I changed number 6, so it's 5, 5 root 3, and 10. This is actually the C. So does 5 squared plus 5 root 3 squared, does that equal 10 squared? Now 5 root 3 squared, I can do that on the side here. 5 root 3 times 5 root 3 is 25 root 9, which is 25 times 3, which is 75. So does 25 plus 75 equal 100? Sure thing. Yes, it does. And that's, again, another special one we're going to come back to. So a nice, easy review of Pythagorean theorem with some trickier problems, but we can handle it.